All right. In the second part of Lesson 3, we're going to look at vector subtraction of 3 or more vectors, or 2 or more vectors, where the vectors are just in quadrants, so they're not all on the x-axis. So the vector A, B, and C that I'm looking at are the same vectors A, B, and C that we used on the previous page of notes. So I'll go back and look at that real quick. So the vectors A, B, and C are the same vectors that we used on page 11 of the notes. And now we are taking the vector B minus the vector A, so the vector B minus the vector A minus the vector C. Now, if you recall, we don't really ever think of vector subtraction. We think of vector addition of the negative vector A and addition of the negative vector C. So we have to go back to our original vectors and first generate the vector negative A and the vector negative C. And once we've done that, now it becomes a vector addition. We do everything as tip to tail like we normally would. So let's go back real quick and look at our original vectors. So with our original vectors, we have vector A, vector B, and vector C. So we're taking, in our vector subtraction, vector B minus vector A minus vector C. So to get minus vector A, what we're going to do is 180 degree vector A. So the 180 degree version of vector A becomes vector negative A. So this is vector negative A. And we're going to do the same thing for vector C. Now it's going to get a little sloppy here. I'm going to draw it in and then erase it. But we would take the vector C and we would make the 180 degree version down here. So that's the 180 degree version of vector C. So that becomes vector negative C. Now once I have my vector negative A and my vector negative C, now I'm doing a vector addition of vector B plus vector negative A plus vector negative C. So let's see how that works out. All right, so our 0th step is to draw in vector B as is from the origin. So we have 0, 0 down here, and we're going to put in vector B without changing anything. Again, I'm doing this with my ruler and protractor, so I've just measured the vector B, measured the angle, kept everything as neat as I could, put in vector B. Then I do my little coordinate system at the top to help me keep things straightened out. Now notice I'm putting in the 180 degree version of vector A, so that's vector negative A, but I put it in as a tip to tail vector addition of negative A, and then at the end of that, I'm going to keep my axes all lined up. And remember that messy vector negative C? Well, here it is, drawn in from the tip of vector negative A. So my vector addition has now ended way out here. And if I just measure everything with my ruler and protractor, I measured this to be approximately 30 degrees, and I measured R to be approximately 8 centimeters. And again, if you do things neatly, I can guarantee your numbers are going to be close enough to get full credit. You do not need to worry about having your numbers be exactly to my numbers. Okay, so take a moment, do that with your ruler and protractor, see if you can get the resultant drawn in, so we have a real firm idea of what it should look like. And the last thing we need to do is then take the vector, we're going to take the addition of vector B and subtract vector A and subtract vector C. So if we do our component form, which again, mathematically you really want to work in component form because it makes the addition and subtraction of vectors as easy as adding and subtracting the x's and adding and subtracting the y's. When we're doing subtraction, you want to make sure you distribute your negative through. So I distribute the negative through for both the x term and for the y term for vector A, and the same for vector C. When I distribute the negative through for vector C, I get a positive 6.9 and then a negative 2.1. And then I add and subtract my x's, I add and subtract my y's to get my resultant vector. And let's see if my original ruler and protractor estimate of 8 and 30 is pretty good. And when we do Pythagorean theorem on my resultant vector, I get square root of 6.9 squared plus 3.83 squared, square root. So I get 7.72 instead of 8. So, yeah, it's off a little bit. And theta is 28.89, off from 30 a little bit. But again, they will definitely be close enough that if you are careful with your work, there will be no problem with your getting full credit. And your homework now that you're going to have is going to be hopefully having you work through them individually and gain confidence that you can repeat these types of solutions. Please look back on your notes, as always, to help reference.